Now let's look at the general sine wave. So we have such a general sine and cosine function, a times sine of the b times x minus c and then plus d, or the y equal to a times cosine of the b times x minus c and then plus d. So the graph of these two functions are both the sine wave. And then we can determine the amplitude. The amplitude of this sine and cosine functions is equal to the absolute value of this coefficient a. And we can also get the period. Okay, so the period is 2 pi divided by the coefficient of this x. And then we also get the phase shift c. So you must write your sine and cosine in such form to determine the phase shift. And then after you get the graph of this part and this part, you do the vertical translation, okay, by the d unit, so the absolute value of d units. Now let's see the procedure for graphing a sine wave. Okay. So if you have a sine function like this, or the cosine function like this, the first step is to sketch one cycle of the sine of bx or the cosine of bx on this, okay, interval. So this is the fundamental cycle from the 0 to 2 pi over b. 2 pi over b is the period of these two functions. And after you get the graph of these two functions on this fundamental cycle, then you change the amplitude of the cycle according to the value of a. So if a is bigger than 1, you stretch the function. If a is less than 1, you shrink the function. Okay, you shrink the graph. Now, if a is less than 0, then we need to reflect the curve in the x-axis. Actually, let me show you one example. We know y equal to x squared. This is the function of parabola, right? And its graph is like this. Okay. And how about the y equal to negative x squared? This is also a function of a parabola. And then we can get the graph of this guy by reflecting the graph of this function in the x-axis. Then in this way, we get this graph. So if you change the sign of the whole function, then the corresponding graph is just the reflection of the graph of original function in the x-axis. Now let's come back to this procedure. So step 4, translate the cycle absolute value of c units. See here the c. To the right if the c is positive, to the left if c is negative. And also the last step, translate the cycle absolute value of d units upward if the d is positive, or downward if d is negative. Actually, when we learn the Math 135, we know the procedures for multiple transformations. Okay, so the step 1, we need to do the horizontal translation. And step 2, we need to stretch or shrinking. You see, if you compare this one with the procedure we just mentioned, here, first one, after we sketch the fundamental cycle, and then we do the stretching, right? And then we reflect this graph about the x-axis. Now let's come back here. Then step 3, reflecting. Then the last step, do the vertical translation. So this is the stuff on the page 218, and you can go back to review the chapter 2 in the Math135 of this book. So now let's apply this procedure to do one example to see how we graph a general sine function by doing a sequence of the transformations. Now let's look at this example. We need to determine amplitude period and the phase shift. And sketch 2 cycles of this function y equal to -3 times cosine of 2x plus pi and then plus y. So first, what is the amplitude? 3, right? Is the absolute value of the coefficient of this cosine function. So this guy is equal to the absolute value of 3, -3. So that is 3. Then, what is the period? Pi or negative pi or anything else? You need to use the 2 pi divided by the coefficient of x, right? So divided by this 2, then you get pi. So the period is pi. Now the phase shift. What is the phase shift? Phase shift negative what? Pi or anything else. When you try to find the phase shift, you need to write your function in this standard form, right? You have to factor out the coefficient of this x. Okay, now let's come back to the problem. So for our function, if we factor out this coefficient, then we would have y equal to -3 times cosine of 2 n times x minus negative half pi and then plus 1. You see, negative, positive. So half pi times 2 get a pi. So then just go back to this original expression. So try to factor out this coefficient of x and then rewrite the expression inside the parenthesis as the x minus something, right? So right now this is your phase shift. So that is equal to negative pi over 2. Right? Now, let's determine the fundamental cycle of this function. We know the fundamental cycle of this function occurs for x for 2x plus pi between the 0 and the 2 pi. So we need to solve this inequality to find the interval for the x.